This presentation is going to be about GitHub Actions, protecting your CI from attackers. Hello, everyone. This is my fourth SAN Summit and the second CloudSec Next event that I participate. So I'm happy to be here and share this presentation and this talk with you. This is kind of the first time I'm presenting around this topic for in a SANS event. And it's a fairly new research that I did beginning October last year, and I published an article in January this year, and I'm going to talk about the how I came up with the idea to do this research and understand more about GitHub Actions. Yeah, just the first slide is just a bit of an introduction about myself. As Eric mentioned, right, I'm information security specialist. I work for Trend Micro here in Canada. We finally can say that we have spring now, because just last week we had a little bit of, not a little bit, a lot of snow actually one day. But yeah, I'm doing a lot of the cloud and container security research for Trend Micro for over 2 years now. And also starting to investigate more around open source security and kind of cloud native technologies, not just Kubernetes, as I presented last year here at the CloudSec Next. But yeah, I also have kind of a personal blog, which has pretty much just kind of my personal information for social media and how to see my, okay, good. So yeah, I have a personal blog there, katanasec.com, which basically has all the previous presentations and events that I participated. I've been presenting in IT and security at many different events since 2011, so over 10 years now. And yeah, my current focus has been around Kubernetes for the past couple of years, and now also focusing on other cloud native projects and open source security as well. So yeah, this is kind of the agenda for today. It should be fairly simple. We're gonna give overview about GitHub Actions and what does that mean. Then we're gonna talk about some vulnerabilities, what is out there, what is known in the field around this service, and what kind of the attackers are doing already to compromise GitHub Actions and mine cryptocurrencies and all that stuff. Then I'm gonna talk about the attacks that I performed during my research, the testing that I've done, scanning, and the results that I got. I'm going to talk about the things that worked and things that didn't work. But if you want more details around that, there's a lot of all the public information is shared in my article there. The link is on the slides, and I think I posted that on the Hallway channel as well, my Hallway channel, Hallway Magna Logan. So there's a link pinned there as well to this article. And after that, just a few countermeasures, right? Some best practices, some guidance, how to avoid some of these problems from happening on your infrastructure, especially if you're already using GitHub Actions. So yeah, that's gonna be kind of the main topics for this presentation. And before we move on, I just wanna give a shout out to my colleagues at Trend Micro, Alfredo and David from my team there, who helped me with this research. I was asking questions and kind of, okay, I'm stuck here. Can you help me? What should I do there? And yeah, they are also part of the cloud and container security research team. So thanks to them for this research. Okay, so my first kind of introduction to GitHub Actions was during the SANS training, the SEC 540 event, the course that I took last year in August, I think, and was kind of like, I've heard about the topic before, but I haven't played with or haven't understood what was going on, all the differences. My previous experience with other CI environment was mostly with Jenkins. So yeah, okay, let's understand the GitHub Actions CI/CD, what it means and what does it do, right? So GitHub Actions is basically a CI environment as a service, right? So instead of having your own CI solution where you have to install and maintain and update on your own environment, on your own servers, such as a Jenkins, for example, which is kind of one of the most well-known CI tools out there. Now you have this service that's provided by GitHub that does all sorts of automations for you. You can build your binaries, you can generate your Docker images, you can perform automated testing, scanning, source code reviews, and all kinds of stuff. So for me, it was very kind of interesting and convenient when I learned about GitHub Actions. And okay, if I'm using a GitHub repository, doesn't it make sense for me to use GitHub Actions already, right? So you have this kind of automation. And yeah, the way that GitHub Action works, you have your YAML files, right, which need to be stored in a specific directory, which is the .github/workflows inside your repo. Remember, because if you just type workflow, that's not gonna work. And was kind of one of the first problems that I was facing is like, okay, I'm adding this YAML file there in this directory. Why is not triggering any actions, right? And of course, you need to have the right directory for the actions to work. And the idea is that your automations, your events are going to run based on any kind of events that happen inside your repo. So for example, a push event or a pull request event. So anything that changes your repo can trigger several different actions or automations that you have inside that directory there. And what's interesting about GitHub Actions is that you don't need to maintain the server. So when you run an automation, when you use GitHub Actions, GitHub will provide this server for you. Of course, you can have your own self-hosted servers, but if you have that available, unless for specific reasons like compliance or anything, but why not use the ones that are provided by GitHub, right? And since GitHub is owned by Microsoft owns Azure, so these kind of servers, these what we call runners, they run on Azure. So they kind of spin up a server for you, they run your automation, they provide you the results, and then the server dies. And it's not actually spin up because the servers are already there. They're just idle waiting for an automation to trigger them. But we'll get to that, more about that in a second. And it's like free tier for any kind of accounts. You don't need to have an enterprise GitHub. If you just have your regular GitHub account, that's available for you already. You can start playing right now. Just create a public repo and start playing with GitHub Actions. So this kind of summarizes a little bit of what GitHub Action is. So just a quick example here with the image, right? So you have an event. An event is something that happens inside your repo. As I mentioned, there's kind of a huge list of events that GitHub has documented there that can trigger automations on your repository, right? So you can specify which kind of events you want to trigger that automation. And from that event, then it's going to create or allocate, more specific, allocate runners, which are basically VMs, servers inside the Azure network, right? Because as I said, it's my Microsoft all behind that. So it's servers inside Azure, they're going to run your automation. And the automation is basically whatever is specified on that script. And it's going to run, you can build your project, you can generate binaries, you can run testing. So you can run all sorts of things. And you have different sorts of runners, right? You have the Windows runners, the Linux, and the macOS one as well. So it's pretty handy, especially if you're dealing with macOS development, because that can be very tricky to test and spin up those environments. And inside those runners, you're going to run jobs, right? And these jobs can contain a script, like a shell script or a PowerShell, whatever is your runner, and if it's Windows or Linux. But it can also run actions. So my action can call someone else's action, right? So it triggers kind of a dependency here. It's a third-party action from someone else that I can call, and it has already all the scripts for me to kind of build my environment or compile my code or run some testing. So I don't need to reinvent the wheel. And that's kind of one of the neat things of GitHub Actions, and why I think it's getting so many adoption, and it's because of the third-party actions, or the GitHub Actions Marketplace. And the marketplace, it's increasing by a lot. Anyone can develop their own actions and publish that to the marketplace. So you can use whatever it's developed out there to run your own actions. So think of that. It's a similar approach to the Jenkins plugins, right? So if you use Jenkins CI before, where you have different plugins to help you with automations or connecting you with different tools for static analysis or dynamic analysis, now you can use this marketplace to run your automations on GitHub Actions. So that's very interesting. And of course, as I mentioned, anyone can generate or create new GitHub Actions and publish that to the marketplace. So if you're in security already, so you can see that there can be some problems around that, right? So if anyone is publishing that, who's vouching them, who's assessing them for security, or who's at least making sure that they are trustworthy and their action is not malicious and not compromising your environment, right? That's kind of the tricky part here. And I think this number is already outdated. Like I think I just checked today, and it's over 13,000 actions available in the marketplace for all categories. So you can see that this is increasing a lot. And I think when we did, if I recall correctly, when we did the SEC 540 training back in August, was half of that, was 7,000 or something like that. So was almost half of that. So it's increasing a lot. Okay, so let me just give you an overview of what an actual action file looks like. So it's a YAML file. If you're doing stuff on the cloud and cloud native stuff, you probably played with YAML before. If not, I'll just do a quick overview of this YAML, this action workflow, and we're gonna just basically go step by step and understanding what is it doing, so that we can understand the other examples when I start playing with actions and attacking different kind of automations there. Okay, as I mentioned, right, it can be any name for the file, but it has to be a YAML file that needs to sit inside my .github/workflows directory, right? So if I don't have that directory yet on my repository, I need to create that. And once I create and have that YAML file there properly created on that repo, then a tab called action is going to show up on my GitHub to show my automations and results of my testing and logging, kind of the similar to the console output of Jenkins. So just making some analogies here to make it easier for people to understand if you haven't played with actions before. So on the right side here of the YAML file, first you have the name, right? The action needs to have a name. And the second directive, I would say, it's the on, right? The on, it's like, okay, when it's going to run, right? The on can be, as I said, an event. It can be a push event, any changes to the directory. It can be a pull request. But in this case, it's a schedule, right? Running at midnight every day via the cron tab. So a similar approach to the Linux cron tab here. And also can run manually, which is called this workflow dispatch. So I can trigger that workflow manually from my repository or via the GitHub API. Okay, And now, what is it doing, right? Once I trigger this automation, whatever, if it's the schedule or the workflow dispatch triggers this action, what is going to run? This is Nuclei dash scan, right? So I'm using the Nuclei automated scanning tool to scan probably my server, right? My web application, it can be an API, whatever you're testing there. And this job, I'm calling this job as Nuclei scan here. So under jobs, we can see the Nuclei scan, and runs on means the server, what type of server I'm running this action on. So there is a specification for each server on the GitHub action, and the Ubuntu latest, it's similar to kind of uh, a tag from Docker, but this is not Docker. This is not a container. This is a server that's provided for you from GitHub Actions. So I'm using the latest version of Ubuntu available as the runner inside GitHub Actions, which is inside Azure. Okay. And then these are the steps that I'm doing, right? So there's steps. It's interesting because, as I said, the step can be a script or it can be another action. And here I have like actions / checkout at V2. So what's going on here? I'm using somebody else action to do some automation first. So these actions / checkout, this represents the specific public repo, github.com / actions / checkout. So if you type that in your browser and go to that repo, you can see the code that should be running when I call this action. And what's interesting about that is these actions, kind of username or organization, this belongs to GitHub. So these are GitHub developed actions and automations provided to the community. So you can leverage that as well. And you can consider that somewhat trustworthy, right? It's developed by GitHub. They're the one maintaining the GitHub actions. So you probably can trust that action. But on the second step here, where I have name Nuclei dash scan and then uses project discovery / Nuclei dash action at main, right? And that at V2 or at main are kind of the versions of that action. You can have different versions or different releases as well. So that going to translate to this specific public repo, github.com / project discovery / Nuclei dash action. And that's where you're going to see the code of this automation, what's supposed to be running there. And this is basically running the Nuclei scanner and specifying the target here. So I have the parameters with target, the website example.com, right? So I'm just scanning that website and I can change that on my own repository to scan my own website. Okay, the second, third one actually, the workflow artifacts. As I mentioned, after the actions are completed, after your steps are done, the server is done, is deactivated. You don't have access to that anymore. You don't have access to the logs unless you can see there on the console output, but you can't get or grab any kind of binaries or outputs from that server. So you need, before you finish your automation, you need to upload that somewhere. And that's kind of what's happening here. The third and the fourth automations are basically, one is uploading the log from Nuclei, from the scans, the automated scan, the dash scan, to my GitHub repo, right? So it has specific actions. Also, you can see actions / upload dash artifact is a specific actions from GitHub to upload the artifact. So I can see that directly on my repo. I can download that file and see the results even after this workflow has completed. And a similar approach with the alerts there, upload the serif results. So serif is a kind of file format used for static analysis and dynamic analysis as well, that GitHub likes to use. So I think it was developed by Microsoft, if I'm not mistaken, but it's just generating the other file in another format, the nuclei.serif, that you can use to import into different tools and kind of go through the triage the results from the dash scan. So this is basically kind of summarizes what a GitHub action file, YAML file looks like. Of course, there are many different things that you can do with this automation, but it's kind of out of the scope for us today. Is just to give you an overview of what a GitHub action looks like so that we can go into the more kind of the attack phase. When I started researching about GitHub Actions, there were some vulnerabilities already disclosed, and even from GitHub themselves, talking about these kind of main issues that they dealt with in the first years that they released GitHub Actions, right? So it was published. GitHub Actions was released in 2019, so kind of less than 3 years old now, and so they faced some issues in the beginning. The first issue is the pull requests from forked repos. What does that mean? It means that attackers were forking your repositories that were using GitHub Actions and submitting pull requests back to your making changes or anything, and then submit pull requests back to the original repo. And that was triggering the GitHub Actions. And what they're doing with that is that they were doing automations to basically mine cryptocurrencies, right? So they would change the action and have access to the repo. And I'm going to show an example here in the next slide. But they were doing this, forking many different repos and sending pull requests to mine cryptocurrencies at the end. And I have an article coming up in the following weeks, but probably this month, around this, analyzing all these different crypto miners and cryptocurrencies inside GitHub Actions to go into more detail. So stay tuned for that. There's also the ability for command injection, right? So command injection via untrusted inputs. And what we're going to focus on this talk, it's basically the malicious GitHub Actions from the marketplace. So here's just an example of a pull request from forked repos, right? And someone was mentioning on Twitter that attackers were kind of forking and sending pull requests to many different repos, as we can see here on the left side. And this is kind of a sample of the crypto miner that it was installing and mining cryptocurrencies on behalf of that user, their original user, of course, but leveraging Azure resources, right? So it's very tricky because, right, it's like the crypto miner, the attacker is getting all the money, but it's leveraging this other user, which is leveraging Azure resources. Also, there's a possibility of command injection via untrusted inputs. So all these fields that you can access via GitHub Action, they can be manipulated and altered by the user, the one that's generating the action or submitting the event. So be very careful when you would deal with these fields and you using that on your actions. Make sure that you have proper input validation, right? Using allow list and verifying whatever you're seeing there, if that expected that information, that input. There's also some issue with kind of templates injection. So as you can see here, the first example of this action that's being called Atlassian Gajira, it's different than the second example, right? The first example is what's supposed to look like on GitHub Actions, but the second one has a $sign in the beginning. This is creating kind of a template injection, and this can generate also different problems. Okay, malicious GitHub Actions. That's kind of the main topic that I cover on this talk today, and kind of the main thing around the article and the presentation. But the problem is, and that's where I found myself kind of concerned about this problem, is that anyone can post actions to the marketplace. So you can see this action, if you're using someone else's action, as a third-party dependency, just like what we have with libraries, right? With the case what we had, the log4j and Spring4Shell recent vulnerabilities, right? So you can have that issue with actions as well. If you're using an action from a malicious or, I don't know, untrustworthy attacker, then you can compromise your repository as well. So two kind of quick things here is when you're using someone else's action, first thing is there is a kind of a verified badge similar to what we have on Twitter. It's creator verified by GitHub as an example here. That doesn't mean that the action was scanned for security or for malware or any malicious purposes. It just means that the creator was verified by GitHub, but at least it's something, right? Also, my second recommendation is like check their code before using. As I mentioned when I was describing the YAML file, these actions always translate to a GitHub repository. So for example, the action/checkout is github.com/action/checkout. So you can go directly to the repo and scan their code, download, read, whatever you want to do with it before you start using on your own projects, on your own pipeline. So what I did with playing with the GitHub Actions that was interesting was the first thing is technically you don't have interactive shells on these automated environments, right? So if you try to get a TTY or any kind of interactive shell to run commands on demand or whatever you want to do it, that's not going to work, right? If you try that through the regular means, that's not going to work. It's going to get a message there, TTY is not available and all that stuff. So I kind of created a simple script to make a backdoor, right? Connect back to another instance that I had that was running on AWS at the time, an EC2 instance, to connect to that instance and then be able to run commands on demand so that I can study, because if every time I make changes or was testing something, I had to run the pipeline, run the action again, that would take a lot of time and it would be kind of, I would still be doing the research today. So one of the things that I did was, okay, now I can run netcat, connect back to my instance and do this, do whatever I want to play with it, right? Start to play with the environment, the runner, the GitHub runner that I have here. And the first thing that I noticed was, first, the netcat that was installed and available on the action, because they have a bunch of programs installed already to run your automations, and you can see that from the GitHub action documentation. It didn't have the specific feature that I needed to run my backdoor, right? So I had to install one from scratch. There are other options to do that as well. I think someone mentioned in another discussion, there's the original version of netcat that has the -e feature to run the backdoors or perform commands. Another interesting thing was I try to connect back via different ports. So I don't know, port 5000 or something like a high number port. And it didn't work because Azure was blocking me. But once I started using the port 443, everything worked out well. So that's great. But what I did was I created a separate action, right? So that's what we're seeing here on the slide. I created a separate action, a third-party action called fake GHA, GitHub Actions. And I'm calling that from my original action that I use in the testing, which is the GHA-test. So I have like kind of trying to replicate or to simulate someone else's action. And once I did that, I was able to, on my own action, to call this Magnologans like fake GHA. And once I run that on my environment, I got a shell. So I got a shell on my EC2. You can see here the EC2 instance. You can see that I'm running, the username is runner, and it's inside the group's Docker. And you can see the name of the machine there, Linux, but it's like Azure, Ubuntu. So you see that's inside the Azure environment. And so what I did, what the attacks that I performed there, right? First, of course, I want to run some Nmap. I want to do some reconnaissance inside the Azure network. I also did the reverse shell, right, from the runner to an external server. But I can also use this action or this server, right, the runner, to perform attacks to other targets, right? And kind of pivot these attacks to avoid detection. So the attack wouldn't come from my own environment, it would come from Azure or whatever server that I'm compromising there. So this is kind of what I did. Here are some of the results running the Nmap inside the Azure network. This is kind of the ports that were open. And as I mentioned, this is not a container. This is a VM servers that are available for you. And most of them are kind of idle there, waiting for you to use them. So it's interesting because they're very quick to start once you start your action. And I thought, this can't be a VM. They're not spinning up a VM from scratch and running that so quickly, right? So yeah, when I was reading the documentation and dig deep into it, I noticed that these are servers, VMs provided by Azure, but they are kind of, some of them idle, just waiting for your action to run or be assigned to this runner. And so you see that the ports open here, kind of pretty straightforward, 2280, 443, 3389. But then there is a server running, a web server running on port 884. So if you want to see more details about this web server, which still intrigues me, and I haven't solved the problem yet. So if anyone want to help me there, there is a web server running on this port, and it's enabled by default, which I don't know why exactly. So it's tricky. I try to analyze the web server, downloading the source code. It's a very old server there. That's, I forgot the name. It's Mono XSP. Yeah. So it's available. Core source code is available. I can give all the information, but it's interesting that it's there and it's enabled by default and exposed to the network. So yeah, once I'm able to do the reverse shell from the runner, right? I can get this as well. And pivot attacks. I know I'm almost out of time, but just finishing up here. So you can issue malicious commands. You can trick the source of your attack, right? And you can either scan Azure itself or other targets. So you can do all sorts of things. There are more details on the article that I shared. But just as for countermeasures, these are kind of my bullet points or recommendations, right? Make sure that you only use actions from trusted creators, right? And set the right permissions for your actions, right? Some actions can have or may need permissions such as read and write, and others only may need read. So just check on that as well. Do not run actions from forked repos. So GitHub implemented a protection around that forked repos issues that I mentioned before. And also, of course, protect your secrets and verify untrusted input, right? So you have a GitHub token, which is valid while your action is running. So make sure you protect that token and don't allow that to be leaked anywhere else. So this is kind of where these recommendations or protections are located inside GitHub itself. So you can play with those settings for your environments. So yeah, that's all that I had today. And I'll be available on Slack for questions. I know I'm a bit over time, so thank you for having me.